All right, here we are, AP Calculus, Lesson 2-4, Advanced Power Chain Rule. Today's date is Tuesday, September 22nd, 2020. Our objective today is to do what, Fiona?
Apply the chain rule to the powerhouse for complex problems.
There it is, yeah. All right, so I need to talk about the difference between complex versus the simple. Like we saw simple forever ago now, like on Friday, right? In lesson 2-3, and today's the complex. So let's identify the simple. So if I had the derivative of x squared, tell me what that is. It's something times something. You can get, let's do the flashcard definition. Whenever I take the derivative, you always multiply the blank by the blank. Who knows it? Who knows this flashcard? Teflon, go for it.
Wait, maybe I don't know. Never mind.
Andrea, go for it.
Daughter times dinner.
There it is. Everyone turn on your microphones and we're all going to shout this out 3 times because you have to have that flashcard memorized. Whenever you take the derivative, you multiply the doubter by the dinner. Again, you multiply the doubter by the dinner. Come on, guys. You have to say this with me. Whenever we take the derivative, we multiply the doubter times the dinner. No one is saying it with me. Whenever you take the derivative, you multiply the doubter by the dinner. Come on. I'm going to do this over and over until you guys say this with me. I'm not even seeing any mouths moving. Chris, turn your camera on. Whenever you take the derivative, multiply the doubter by the dinner. I'm talking lightly so I can hear you guys. Whenever you take the derivative, you multiply the
doubter times by the dinner.
Last time, whenever you take the derivative, you multiply the doubter by the dinner. All right, I mean, it's hard with Zoom, but there it is. All right, so what is doubter? Teflon, what is doubter of this x squared function?
X? Or would it be 1?
Well, let's just identify the outer, I guess. So there's my parentheses to help you out. What's the outer?
Oh, 2.
Yeah, something squared, right? Something to the power of 2. So if I take the derivative of that, it's a powerhouse. The 2 does what?
It goes out to the front.
Okay, so it goes out to the front. And then we relist the inner, right? And what was the inner?
X.
X. So really we just have 2x. Perfect. So that's the doubter because it was the house that came down in front, and then we relist the inner, and then we multiply by the dinner. So this is the inner, known as dinner. Again, the inner is this x over here. So what is the derivative of that inner, Chris?
I don't know.
All right, so I'll give you a hint. The derivative of 2x is 2. The derivative of 3x is 3. The derivative of x is?
X. 1. Is it 1?
1, exactly, yeah. So the derivative of this inner, which is x, is 1. So come back up here, undo those. Dinner is 1. Perfect. Next. I need to take the derivative with respect to x of this 3x to the power of 4. Someone do doubter between Andrea and Fiona. Fiona, go for it.
12x to the third.
12x to the power of 3. Perfect. And Andrea, what's the dinner?
Be 3x. No, wait.
Not quite. So
4.
remember that the inner is this x.
So 1.
1, exactly, yep. All right. For this next one, Teflon, what is the inner of this term right here? Just identify the inner, not the dinner, but just the inner.
10x? Oh, the dinner. My bad.
So I don't want you to take the derivative, nothing like that. Ignore the derivative right now. What is the inner of this function?
Negative 5x.
No, not quite. No. It's going to be the most inside thing, and I've put it in parentheses up here and here. So this is the inner, this is the inner. Our inner is going to be
X.
It's just going to be x again. Yeah. Yeah. So being able to identify what the outer and inner is, maybe I should have had you identify the outer first because it'll make the inner more clearer, I should say. Yeah. So the inner is just x, which means this outer is this -5 times something to the power of -2. All right. And then Teflon again, go ahead and do doubter for me.
10. X.
10 x. Yep. Perfect. So 10 is that outer part of the house, and you always need to multiply by whatever the inner was. So we had to multiply by x again. Okay. And Fiona, give me the dinner.
1.
1. Yep. And you guys are seeing the pattern here. Dinner is always 1. I wonder what's going on. That's what it means to be simple. Simple is when the dinner is 1, which means you really are only multiplying doubter, or doubter times nothing. Doubter times 1. All right. So
1.
say that one more time.
Do you still need to subtract 1 from the -2, or no?
Oh, we do. Yeah. We totally forgot to do that. So what is the power that we should have, Teflon?
-3.
-3. Good catch. Yep. I can have slightly better handwriting. -3. All right. And what about this next one? First, identify. We're still in Powerhouse because this whole lesson is dealing with Powerhouse. It says only one house that we're dealing with. We're in Powerhouse. What's going to be doubter? Chris, help me. What's doubter?
I don't know.
Okay, so we're going to multiply this power down to the coefficient. Half times 6. What's half of 6?
Would it be 3x?
3x, okay. And then after we multiply down, we're going to subtract the power. So a half minus 1.
I don't know.
I'll help you out. So a half minus 1 is the same thing as a half minus 2 over 2, because now I have like denominators. What do I have for the numerator and denominator here, Chris?
Oh, is it -1?
-1, and then denominator is
0.
not quite, it's still 2, which means our power now is this -1/2. -1/2. And this is something that you're going to be seeing over and over again. I'll have a power of a half, and then when I take the derivative, it's going to turn into a power of -1/2. Something that you just want to have memorized so you don't have to do all this long math in your head each time. All right, and then I'll do this last one. Yep, dinner is still 1 because the inner was x. Okay, now the inner is not going to be just x. It'll be maybe a little bit more than that. So it's what I am asking for when I say it's a complex number. Okay, so these complex problems for Powerhouse, the chain rule. Again, I'm still going to be multiplying doubter by dinner. And doubter is basically going to be the same thing. Notice how this problem is very similar to this problem up here. This problem down here is very similar to this problem up here. They're just, I'm changing what the inner is. The inner is no longer just x. I'm making it a little bit harder. I'm making it complex. Okay, so maybe I should have the screen right there. All right, then what do I do? What's doubter? Andrea, help me out. What's doubter?
2 times, in parentheses, x plus 3.
There it is, x plus 3. Exactly, because the inner right now is this x plus 3. The parentheses are already here, x plus 3. That matches the inner up here of x. Again, I just multiplied this 2 by whatever the inner was. I multiply the 2 by whatever the inner was. You see the direct correlation between these two problems now, okay? From there, what is the dinner? Slightly harder. The derivative of this inner, that is x plus 3. So I'm essentially asking you, what's the derivative of x plus 3, which you've done over and over again in the previous homeworks. What's the dinner here? Fiona?
1.
It's still 1, yeah. So it's one of those kind of rare cases where it's a complex problem, but the dinner's still 1. Can you explain why it's 1 more time?
Because the derivative of x is 1, and then the derivative of 3 is 0.
Perfect, yeah, thank you. All right, let's move down to the next problem. Again, it looks very similar to the problem up here. Instead of the inner being x, the inner is now 4x to the power of 3. What's the doubter? What's the dinner? Who can help with doubter? Yeah, Teflon, go for it.
12 parentheses 4x to the third to the third.
To the third, exactly, yeah. And look how it's like, it's the same thing up here, except the inner has changed to this 4x to the power of 3. Perfect. Okay, this is where the dinner is not going to be 1, finally. Chris, what's the dinner?
Oh wait, wouldn't it just be 12? 12x?
12x, yeah, so that's how it starts out. 12x because the 3 multiplied down to the 4, 3 times 4 is 12. Okay,
12x
what power do I
squared?
have? 12x squared, there it is. Nice. All right, let's move on to the next one. Again, direct correlation here. Who can help me do the doubter? And we're gonna have to kind of squeeze it in here, right small. What's doubter? Probably just gonna cycle back again. Andrea.
It'd be 10 and then x squared minus x to the negative 3.
There it is, -3. I'm really hoping you guys are looking between the simple version up above and the complex down below and seeing how they relate. Okay, and then what about the dinner, Fiona?
2x plus or minus 1.
It's 2x minus 1. All right, and then our final problem. I'm gonna maybe switch things up. Let's give Chris the doubter, and then we're gonna give Teflon the dinner. So Chris, what's the doubter?
It'd be 3 parentheses x minus x cubed.
Yep, keep going.
Would that just be negative half?
It is indeed -1/2, just like last time. Yeah, nice. And then
Okay.
Teflon, what's the dinner?
1 minus 3x squared.
There it is. Yeah, good job, guys. And of course, each of these would eventually need to be simplified, so we can do that really quickly off to the side. So I can say, yep, that's just 2x plus 6 because I just distribute the 2. In fact, some of these need to be simplified as well. Like sometimes you want a negative power because multiple choice. Sometimes you don't want a power, so you have to be okay with both of these. But you might say, yeah, this is 1 over 10x. Ooh, oh my gosh, Mr. Sindel. Okay, I'll leave it there. 1 over 10x to the power 3. There's a mistake there. Who can find it? Extra credit point if you can log in. That's not correct.
Negative 3?
Oh no, I froze. Hold on. Okay, yeah, raise your hand. What's the mistake? You get extra credit if you can find this mistake. Find the mistake. There's like this really big mistake I told no one to make. Raise your hand. I'm waiting for as many hands as I can to get as many extra credit points. You guys need the extra credit. Extra credit is nice in this class. Only one person sees. I froze again. What is going on with my internet? You can only see. Okay, there it goes. 2 people see the mistake. 2 people are going to get extra credit. Andrea, are you raising your hand? Because it looks like you're just frozen. Andrea, are you there? Oh no, okay. Teflon. What's the mistake?
Would it be 10 over x to the third?
Exactly, yeah. Fiona, is that what you're going to say as well? Yep, 10 over x to the power 3. You guys have like a little piece of paper for your extra credit that you're keeping track of right now. Go ahead and log it, yeah, both of you. 10 over x to the power 3. And then down here, this is going to simplify to 3 in the numerator. Oh my gosh, I'm getting weird lag. Over x to the power of, oh, come on. I'm not writing anything. My hands are up and it's going to write magically. Look at this. Isn't it crazy magical? All right, x to the power of 1/2, which again can be simplified further into 3 over the square root of, I hate this lag. It's driving me insane. 3 over x. All right. And then these can be simplified down here for the complex parts as well. Notice that I have 12 times 12, which is 144. So I can say this is 144. If I multiply all of these out, let's do the mental math. This is going to be x to the power of 9 plus x to the power of 2. That's going to be x to the power of 11, right? So I'm going to have times 4x to the power of 11, and 4 times 144, 576. So this is really 576x to the power of 11 if I multiplied all of that out. Down here, trying to do the mental math really quickly. I have a 10 in the top. 10 times this 2x minus 1. If I distribute the 10, I really get 20x minus 10. And then the denominator is going to be this this term because it has a negative power, right? So this can be x squared minus x, all of this to the power of positive 3. And this bottom one is going to be, again, distributing the 3 into this term for the numerator. So I get 3 minus 9x squared in the numerator, and in the denominator, I still have that square root of x minus x cubed. So just know that you're not done after you multiply dinner times, or Doubter times dinner. You still have to simplify. And sometimes the simplification is hard. I know I went through that kind of fast, and if you couldn't follow that, maybe you can rewatch the video or take some time later tonight to be like, how did he do that? Let's go on to example 1 after I see you guys are done. We have just 2 examples, example 1 on the front, example 2 on the back. Looks like you guys are done. Okay, so example number 1. Here's my function. G of x is equal to 4 in the numerator, and the denominator is the quantity of x squared minus 2, that quantity squared. I'm taking the derivative. I say g prime of x now, so taking the derivative. How do I do that? Well, every single time that you see a fraction in this class, be scared. This fraction I'm scared of because we don't know how to take the derivative of fractions, not until the very end of this unit. So I need to rewrite this first. Let me go ahead and rewrite g of x. I want to rewrite this without a fraction. Who can use negative exponents to rewrite this with no fraction? Teflon. Rewrite this with negative exponents, no fraction.
4 and then x squared minus 2 to the power of negative 2.
There it is. All right, so there's no more fraction. We have negative exponents, which is perfect because now we are ready to do one of these houses. We're in PowerHouse still. So I'm going to be multiplying what 2 things? What's the flashcard definition? Whenever I take the derivative, you're going to multiply. Everyone's going to shout out. Doubter times dinner. All right, who's going to do Doubter for us? Andrea, do Doubter.
Negative 8 times the x squared minus 2 to the negative 3.
Perfect. There's Doubter. And I'm going to multiply that by dinner. Chris, do dinner.
Wait, what?
The derivative of the dinner.
Of the top one, right?
Yeah, so this is the thing that we're taking the derivative of. Andrea's done the Doubter. You need to do the dinner.
What is it 2x minus 2?
You're really close. 2x, and then the derivative of negative 2 is
2.
the derivative of any constant, any just number without a variable is just 0. So don't worry about it. It goes away. It's just 2x.
Okay.
So this is our Doubter. This is our dinner. We're going to multiply them together and simplify. We're almost done. Fiona, help me out. How do I simplify this?
Is it negative 16x? times, oh, well, it would be over x squared minus 2 to the third.
The third, exactly. And it really depends on what the multiple choice answer wants your form in. Sometimes they leave negative exponents, sometimes they write it with positive exponents in a fraction. Just know that you should be comfortable with both forms. All right, that's example 1. Give me a quick fist of 5 on example 1. 5 is I understand it really, really well. 1 is I don't know what's going on. 5, 5, 5, and Chris, you're at a 5. Oh, wow, 5's across the board. Okay, let's jump to example 2 then. All right, so, I have a radical. Again, I'm scared of radicals. I can't do that yet. I need to convert that radical form into exponential form using fractions, so rational exponents. How do I rewrite this? Someone help me. Teflon did it last time. I want someone else to rewrite this with rational exponents. Fiona, thank you.
Negative times 2 minus 3x to the 4th to the 1/2.
Thank you. All right. So Fiona has rewritten this for us. I need someone to do Dower times dinner. Teflon, do Dower for us, please.
Would that be negative 1/2 times 2 minus 3x to the 4th? Negative 1/2.
There it is. There's our doubter. Andrea, can you do the dinner for us, please?
Be negative 12x to the third.
There's doubter, there's dinner, and now I need to simplify. You're up, Chris. Go ahead and
Still
get the
negative.
denominator knocked out of the way. Maybe that's easier because this is the negative exponent, right? So what's the denominator going to be?
Would this be negative half? I don't know. Actually. I don't know.
Let's only look at this term, this expression right here. That's all to the negative 1/2, which means it's really down in the denominator as a positive 1/2, right? 2 minus 3x to the power of 4, all to the positive 1/2. And then these two can technically be left in the numerator. Let's multiply negative 1/2 times negative 12x to the power of 3.
Be 6
Keep going.
x cubed.
Cool. And then simplify that denominator for me now, because I don't like rational exponents. I want to turn it back into radical form.
I don't know.
You got this. So when I take the power of 1/2, it turns back into radical form. The simplest form of a radical form is not cube root. It's not the 4th root. It's just the normal.
I don't know.
just square root.
Okay.
All right. And there's our final answer, and we box it. And that's all we have for the notes.